Hello. So today we're going to look at lines and tangent lines, starting with parametric forms. So today we're going to actually add some of the calculus to the parametric things that we've been doing. We're going to start though with something that's not very calculus-y. I want you to consider this set of equations: x equals 2 plus t, y equals -1 plus 3t. I want you to fill in the table and then sketch a graph. And you should be able to do this on your own, so you could pause the video and try it yourself. Otherwise, I'm going to go right here. So if I'll start with a negative. If t is -1, my x is going to be 1, my y is going to be -4. If t is 0, I get 2, -1. If t is 1, I get 3, 2. And you notice that in my x column, I'm going up by 1 every time, which should make sense because there's a 1 in front of my t. And in my y column, I am going up by 3 every time. So I want to sketch a graph for this. I can put in my points. When x is 1, y is -4. When x is 2, so I go over 1, or when t is 0, I get a point 2, -1. So when x is 2, y is -1. And then when x is 3, y is 2. And I get this line. And we could write the equation for this line. If I think about one point on this line, so I have y, and the y value there is 4, or -4. Y minus -4 is my slope, which turns out to be 3, x minus x minus 1. And that's the point 1, -4. There's other equations I could write. I mean, there are multiple equations. I can also write the equation y minus 3 equals, no, y minus 1, y plus 1. Y minus -1 is still my slope, x minus 2. And if you notice from here that my point comes from these two numbers in this case. There's my point, and here's my slope is my 3. And my slope comes from my change in y over my change in x. And you can think of each one as being separate, your change in y and your change of x. If we look in general, rewrite the parametric equation above so it's in the point-slope form of a line. And again, if I think about solving x for t, right, I'm going to do x minus a over b is t, and then my equation for y is c plus d x minus a over b, which is the same as d over b x minus a. And again, where is my point? My point is AC. So the point comes from right there. And my slope is d over b. And that comes from right there. If you think about slope as being dy dx. And you can also get it if you look at my two equations separately. So if I look at my x equation and I consider getting dx dt, the derivative of a plus bt in terms of t is just b. Similarly, dy dt, the derivative of c plus dt is just going to be d. And if I want dy dx, that's the same as dy dt over dx dt, which turns out to be d over b. So there's my slope. Okay? So if I give you this question, write a parametric equation for the line through these 2 points. Again, you should be able to stop the video and come up with this equation. But if I'm writing it, it's as simple as saying, well, give me a point, and you can choose either point. So I'm going to choose the point x is 1, y is 5. And then I need my slope. And you can find the slope either way. You can go 6 minus 5 over -2 minus 1 and get -1/3, right? But what's happening is I want my y piece. So I really want, that's my slope overall, but I want my y piece and my x piece. So my x slope is -2 minus 1, and there's my -3t. And if I do my y piece, 6 minus, and I have to go the same direction both times. So I did -2 minus 1 for my change in x. For my change in y, then I'm going to do 6 minus 5, and that's going to go down here. So there's one possible equation. Now I could have done my slopes the other way, and I would using the same point. And I would have gotten, if I did 1 minus -2, I would have gotten plus 3t. And if I would have done 5 minus 6, I would have gotten minus 1t. Still, overall, the slope of my line is -1/3. Either way, 1 over -3, -1 over 3. We also have the option, in this case, I could use my other point as well. I could say that x equals -2 minus 3t and y equals 6 plus 1t. Or -2 plus 3t, y equals 6 minus 1t. All four of those give us the same line in parametric. The xy points will all be the same. They will happen at different t's, but that's okay. It's the difference of I will draw the same graph. It just will vary in how I draw it. But they are the same line. If I turn them into a y equals, I would get the same y equals for all of those equations. And that is a question to think about. I have two parametric equations. Are these the same line? Well, we know lines are the same. They must have the same point, or the same points, and they must have the same slope. So let's start with the slope. So the slope for my first one comes from my vertical and horizontal stretch. My slope is 3 over 2. Over here, I have a slope of -6 over -4, which is also 3/2. So yes, those have the same slope. Now I need to know, do they have at least one point in common? If you have one point in common and you have the same slope, you are okay. So this point on this graph, say when t is 0, I get x equals 1, y equals 0. So the point 1, 0 is on this first graph. I need to know whether the point 1, 0 is on the other graph. So if I make x equal to 1 and y equal to 0, that should happen for the same value of t. And in this case, if I add my 4t over and subtract my 1, I get t is -6 over 4, or -3/2. In the y equation, if I add I get positive 6t is -9, t is -9 over 6, or so yes, at -3/2 in my second equation for t, I get the point 1, 0. So they both share the point 1, 0, and they are the same line. Another way to think about this is, since I have the same slope, if I go from 1, 0 to the point on the other graph, -5, -9 is my slope 3/2, which is what I said my slope was. Because if it is, then that is the same line. And if I go back 6 from 1, so if I do my 1 minus -5 over 0 minus -9, I get 6/9. So going from 1, 0 to -5, -9 does require a slope of 3/2. So those 2 points must be on the same line, and those two equations must be the same. Okay, so now we're going to make it a little more complicated. We're moving past linear equations into other equations. So I want to find dy dx when t equals 1. So basically I'm finding the slope of y, the slope of the graph, that parametrically drawn graph, when t is 1. And so t is involved, but it's not in my dy dx. However, I can think about just finding dx dt. If I look at this first equation and I take the derivative with respect to x, or to t, derivative of x with respect to t, derivative of 2t is 2, and the derivative of 3 is 0. Now if I think about my y equals equation, dy dt equals 2t plus 1. Now what I want is dy dx. So what I know is that dy dx comes from taking dy dt and dividing by dx dt. Because if I multiply by the reciprocal of the bottom on top and bottom, because that's how I get rid of my bottom, now I have dy dx. What does that equal? In my case, 2t plus 1 all over 2. And I want this when t equals 1. So I'm going to evaluate that for t equals 1, and I get 2 times 1 plus 1 over 2, or 3/2. So the slope of that parametric graph when t is 1 is 3/2. Now I want the equation of the tangent line when t equals 1, because we always seem to want the equation of the tangent line. What do I need when I want to find the equation of the tangent line? That's what you have to ask yourself every time, and we know we need the slope and the point. So my slope is what I just found. My slope at t equals 1 is 3/2. So now I need the point, and I'm going to get that by plugging t into my x equations. So x is 2 times 1 plus 3. My x is 5, and my y is 1 squared plus 1 is 2. So I have the point 5, 2, which makes my equation y minus y1 is x plus my slope. No, that's backwards. No. Y minus y1 is my slope, which is 3/2 x minus x1, which is my 5. And there is my equation of my tangent line. Right? Equivalently, it could be written as y equals 2 plus 3/2 x minus 5. Either one is equivalent. You should be able to switch between them. You should know these equations. Let's try another one. So write the equation of the tangent line when x equals 7. So again, I need my slope and my point. My slope is dy dx, which is dy dt over dx dt. Well, my dy dt is 5. The derivative of the y equation is just 5. The derivative of the x equation is 3t squared minus 0. And I want this, when x is 7. That does not mean I am not plugging in 7. So do not. Because 7 is for x. So I need to find my point right now so that I can find my t. So if x is 7, I'm going to go up here and I'm going to say 7 is t cubed minus 1. Solve for t. 8 is t cubed. So I'm looking at this tangent line when t equals 2. And so I want to evaluate my derivative. So I want dy dx is 5 over 3t squared. I'm going to evaluate that for t equals 2. 5 over 3 times 2 squared is 5 over 12. So I have my slope. Done. Now I have to find my point. Well, I already have my x-coordinate. My x-coordinate is 7. Now I need my y. To find my y, I go back to my original equation, and I say when x is 7, t is 2, which makes y equal to 5 times 2 plus 2, or y is going to be 12. Now I have all the pieces I need for my tangent line. Y minus my y value is my slope, which is 5/12, x minus my x value. Or again, alternately, if you like this better, y equals 12 plus 5/12, x minus 7. You could also write this tangent line in parametric. If I wrote it in parametric, I'd take my point, 7, 12, and I would add my dx dt in the x part. So that's going to be my 12t, and my dy dt is my 5t. And there's a parametric equation for the tangent line. This again would be the tangent line, not the graph itself. Now you should have what you need to know to be able to do your homework, which is right there.